Oh, hello there. I am Ian Littman, and I tried to throw as many TLAs, or three-letter acronyms, in the opening slide of this presentation as possible. To expand them out, we're talking about how to build container native, or actually just get the thing running, container native things without Kubernetes, PHP hypertext preprocessor, in Elastic Containers service on Amazon Web Services. So this is one of two talks that I'm giving here. If you're looking for the other talk that has to do with kind of what my day job is over at Covie, then that is tomorrow. That's web scraping. If you're looking for an open API talk, that's the other one that's happening right now. Just go over there and see Rob do that. And if you're looking for the Kubernetes talk, that's not today, that's Bastion's tomorrow. Now, for all the rest of you who are still here, I am Ian Littman, and, well, let's get into it here. As fair warning, we will be clicking through the AWS control panel, or console rather, throughout this presentation. So this is going to be rather hands-on, at least my hands on my keyboard, guiding you through the process of going from scratch, from nothing except DNS records, because I don't trust DNS to not propagate in time, to a fully functional but trivial PHP-based, barely, web application running on ECS. In, let's see here, about 9 easy steps. So a lot of those are going to be AWS services that kind of run alongside the actual bit that runs the containers, and I'll explain as I go kind of what's going on. So not going to get into a whole lot of theory here, going to get into a lot of practice, and hopefully at the end of this you'll be able to say, yes, I feel like I can go through and set up my own web services using ECS. It's not a black box anymore. Here are how the pieces fit together. So why ECS rather than something else? Well, for my day job, brand new startup, well, last year at this point, sorry, year before last, my how time flies. Never mind that we're like March 538th, 2020. I got the ability to pick our tech stack. Having worked on various things before, I picked PHP with Slim, running on AWS, running containerized, running on Elastic Container Service, because, like, yes, I'm familiar with the Docker workflow. That works well. I can have a Docker Compose file set up locally, and I just want to replicate that more or less in production, except using Amazon's database rather than MySQL in a container or what have you. And I wanted to do that without spending a whole ton of time trying to set up pods and the various Kubernetes primitives, and also that Kubernetes control plane on AWS actually does cost money. So it's like, well, ECS doesn't cost anything except the containers that you're running. The control plane is free, and it's a little bit easier to work with, so that I can spend as little time as possible doing DevOps and get back to actually building the product. So whereas tomorrow you can go to a talk about running between 1 and a million Kubernetes clusters, today the talk is about running 0 of them. And yes, there are about 34, 35 different ways of running containers in AWS. If you looked at the first slide, you saw a link, ian.im/ECS UK22, I believe. And these are links, and you can go read blog posts in detail about how Amazon has way too many ways of running containers. We're picking one of the, I wouldn't say the most simple one here, but one that has a significant amount of flexibility without taking overly long to set up. So, yeah, and again, this is specific to AWS. Google has their own thing, either with Cloud Run or with GKE for Kubernetes. We're kind of not talking about that here at all. In addition, I didn't want to, at least to start with, run actual servers, virtual machines, EC2 instances to run my code. I wanted Amazon to just handle that for me. So on our production environment, as well as in this live demo masquerading as a presentation, we're using Fargate, where Amazon just provisions kind of VMs in the background and lets you use them a quarter core and 512 meg of RAM at a time to run applications. It means that for what we're doing at Covie, we have kind of these compliance needs, and that means that either I have various knobs and controls to log into servers, which means I have to audit that entire chain, or I remove all of those knobs and say, look, I can't log into production anyway, and that's less audit surface, so it makes me sleep better at night. So with that said, here are the 9 easy steps of getting an ECS environment up and running and actually having a web service that responds over HTTPS to the outside world. We will walk through these step by step, and at the end of this presentation, we will have something that at least says hello world over HTTPS. And this may seem like a lot, and it may seem like there's not a whole lot here that deals with ECS in particular, and you would be correct there. It's a lot of other AWS pieces that all work together in Symfony to, not the framework, to build out something that kind of works here. And so you'll get a load balancer, you'll get some Route 53 DNS, you'll get a certificate manager for HTTPS. We won't really go into identity access management roles more than we have to, but we have a bunch of these AWS services working together to get a finished product of a web service that says hello world, and then you can kind of go from there. So with that, let's start off with the thing that I did ahead of time, because I don't trust DNS to propagate quickly enough. I have a domain sitting around cloudihills.com, set that up with name.com, pointed the name servers at Route 53. A reason for doing that is Route 53 allows you to alias your A record back to a load balancer and actually handle that properly rather than having IP addresses and such move out from under you. So for cases like this where you're using an application load balancer in front of your actual app, just use Route 53. It's going to make your life a lot less miserable, even though I really do like me some Cloudflare. I've set that up ahead of time. I'm not going to go into the Route 53 control panel now to confirm that stuff is there. You'll see that later. So first step is make sure that your DNS is set up, because by the time you actually need it, hopefully it'll be propagated. Next up is security groups. So since we don't want this application to be wide open to the world over in Secure HTTP, we're going to set up one security group to go from the wide internet to our load balancer, which we haven't created yet, and one to go between that load balancer and the actual application, which we will be serving over standard HTTP. It's all within AWS's data centers, so yes, you may want to have, in certain cases, HTTPS between the load balancer and your actual application. We're not doing that here. It's fine. It's within AWS's data center. If that gets intercepted, we have bigger problems. So with that, let's hop over to the AWS console and kind of set things up. So let's start. Here. So we're going to name things halfway reasonably here. And we'll have four rules here, because we have to have IPv4 and IPv6 subnets on their own. So what we just did there is now we have a security group or effectively firewall rules saying that if this is assigned, then I can hit it on port 80 and 443 from anywhere. Port 80 will just redirect to the load balancer level later. 443 is where we'll actually serve traffic. Again, that's just firewall rules. We haven't gotten to the container bit yet. That'll be later. So, next up, we're starting to get into the container side of things. Amazon Web Services has a built-in container registry called ECR, or Elastic Container Registry. And we will use that to store our container images and then pull from ECR to actually run our application. There are a few things that ECR does nicely. Number one, it works with Amazon's identity access and access management, so you can put fine-grained security controls across everything. It also does have image scanning, so it'll tell you if there is an operating system level CVE or such, or it'll give you a false positive, which we'll actually see in a second. But by default, ECR is how you push your container images into something that ECS can pick up. Yes, you can use an external registry for that, say Docker Hub or GitHub package repository, but honestly, this is a little bit easier as things go. So, we will go to ECR, Elastic Container Registry. Let's do a private one. And I would normally turn on tag scanning here, but it says, please turn on tag scanning somewhere else, so we'll turn on tag scanning somewhere else. Start the registry there, or repository there. And the other thing we'll do here is private registry, scanning, and make sure that this is turned on. And that way, when I push this trivial image that I'm about to push, then you'll see in the console where it has done the container scan and it has given us results back. So, next thing we'll do here is I will switch over to, okay, let me make sure that this is connected again. Yay for shelling into my machine back home in Austin, Texas. I'm having to unlock the keychain because I'm using Docker for Mac, both here and back at home. And if I don't unlock the keychain, then it's not going to be able to pull the credentials to log in, and nothing's going to work. All right. So now I'm at my local here, and what I'm going to do is I'm going to hop back over to the AWS console, because it'll literally give me the commands to copy and paste to build my image, tag it, and then push it to ECR. We have these nice copy buttons here. The first thing to do will be to log in. Second thing to do, which those are temporary credentials, they will eventually expire. So if you're doing a build script for this locally, then you're going to need to log in basically on every build to make sure that things actually work. Then we're going to build the image, which is trivial. Then we're going to tag it. And the other reason why, well, there are a couple of reasons why I'm not doing this locally. Number one, trying to push about 100 megs of Docker image over a mobile data connection because I don't trust the Wi-Fi is rather ill-advised. And also, this is not an x86 machine. And ECS by default, and I'll mention this in a little bit more detail later, is x86 by default. There's no magic, oh, if you push an ARM image, then it'll run ARM. No, that's not actually a thing. So if I tried to push the image from locally, then things kind of wouldn't work. And you can't even go into the console and fix this, but I'm getting ahead of myself here. So at this point, I have tagged the image, pushed it, standard Docker stuff, pushed it to ECR, and now I can close out of my terminal here because I'm completely done here. But before I do that, well, actually, no, I'll just show you the slide that has the same information on it. So we push this. If I close out of here, refresh this, we have our latest tag. And we have this one low vulnerability, see here, details there. And it says that there is a 2-year-old CVE and muzzle. We're using Alpine Linux here as the base for our image, and for some unknown reason, AWS has continued flagging a false positive on a library that's been fixed for a while. Keep that in mind if you're using that as your base, but if there are more than literally this one low priority issue here, then you may want to run updates on your container and push it again and let the container scan give you a thumbs up. So we've now pushed our image. I said there was going to be PHP in this talk. There is barely PHP in this talk. This is the extent of that. And then pushing the code here, again, it's you log in, you build, you tag, you push. So next, we're finally getting to the part where we're interacting with ECS. So let's build an ECS cluster. Now, there are a couple of different ways that you can configure ECS clusters. You can configure them to farm out tasks to EC2. For our purposes, we're not going to do that. We're just going to start off with something that is networking only, which only really works with Fargate and potentially like farming out ECS to servers that you're running on your own, potentially even not on AWS's cloud, but we're just going to do Fargate for this. And that's actually pretty quick to set up. And one interesting thing is you can tell, even though Fargate is this serverless thing, you can tell Amazon, hey, I could do with my infrastructure being interrupted with a couple minutes notice, give me cheaper instances, and there is something called Fargate Spot that'll allow you to do that. And we actually run our production workloads on that, and it hasn't bitten me quite yet. I'm jinxing myself, but we'll see how that goes. Start a cluster here, set network only, which is the default. We're not going to set a new VPC up for this. We could, but we're not going to. Container insights, we're likewise not going to check because this container will have basically no CPU usage and almost no memory usage, so it's not going to be a pretty interesting graph, but you could add this in and that would give you additional metrics on a per service and per container level that you normally would not get. Of note, these are CloudWatch metrics and they do cost money. Beyond CloudWatch's free tier, so keep that in mind before checking that box. So at this point, we've set up the cluster. We can go in here, and if we want to add Fargate Spot as a, what they call a capacity provider, which is basically a make everything cheaper button. So we've got the ECS cluster set up. Let's go on to step 5. Now, this kind of gets into the weeds. The ECS task definition determines which containers you're going to run. You can have multiple containers in a single task. Think of a task as kind of a miniature virtual machine, so to speak. All those containers are running in the same place. They can talk to each other over the local network, and you can configure environment variables and the like on a per container level, and then roll that up to a kind of this grouping of this task. Before we get into this, I have a couple of notes here. First off, the old console has, as mentioned, a whole bunch of options that don't really apply to Fargate at all. And if you try to tick one of those boxes, then it will just error out with you, and the error message may or may not be helpful. The newer version of the console cleans this stuff up considerably. However, I had issues where it would error out and provide me really no explanation of why it was doing so. So we're going to use the old console UX. Feel free to, in your own experimentation, try the new one and see if it works for you. So these task definitions include things like how much CPU you're using, or you actually have set up. But before that, let's talk about roles, IAM roles specifically. There are actually two different roles that ECS will let your containers take on, depending on what stage of the process you're working at. There is the task role, which is kind of your standard IAM role, which interacts with the container while it's running. So if you need to pull files out of S3 while your container is running, or send emails, or push things to a queue, or anything like that, or call Lambda functions, then you're going to use the task role to assign those capabilities. By contrast, the task execution role is what the ECS runtime uses to build out the container in the first place, to pull the image, hydrate the environment variables, and then start running things. So you have two separate sets of permissions in order to get the container fully up and running and actually doing things. In our case, we won't assign any task level role because we don't call any other AWS services while things are running. But we will use kind of their default ECS execution role, because if we don't, then the ECS environment won't even be able to pull our image. It'll just fail out and say, hey, I can't do it, I get a 403. So keep that in mind as you are kind of building out these task definitions, because where you assign permissions will vary depending on where in the lifecycle you're running. Now let's talk about CPU. Unlike, say, Lambda or such, or your T2, T3, T4 instances, if you look into Fargate in particular and look at the CPU increments that it allows, which I think it allows up to like 4 or 8 cores and between half a gig and 30 gigs of RAM. If you look in there and it says, okay, a quarter of a vCPU, you think, okay, well, that's plenty, right? I can burst up to a full vCPU. It's no big deal. No. That quarter vCPU is capped at 1/4 of the processor time. So your application will be 1/4 of the speed, if it matters, versus a full vCPU. Memory scales at 2 gigs minimum per vCPU. You can go down to 1/4, so you can have a Fargate container as small as a 1/4 CPU and a half gig of RAM. Again, you do have to pick the architecture here within the task definition. That task definition within the console, you can't actually pick anything other than x86. There's not even an option. Fargate does run on ARM now if you tell it to, but you basically have to do that via APIs in the command line, and that's out of scope for this presentation. In addition to that, you'll see in the console UI a bar that says, hey, you can allocate your CPU cores in a certain way. You can tell, similar to what you can do with your Docker CPU limits, you can tell ECS to limit each container to some fraction of the CPU of the entire task. That doesn't decrease the amount of CPU that you have overall, but it allows you to kind of enforce fairness if you have somewhat of a noisy neighbor and you don't want to split that out into its own task or service. Additionally, you can inject environment variables into the container at this point. Those environment variables can either be hard-coded, or you can pull them from elsewhere in AWS. For example, the AWS Secrets Service Manager, one of the two. Some of these service names, like pick one, whether it's AWS or Amazon. So you can pull environment variables from there. Note, though, that even if you pull an environment variable from an external source, if you want to have the container pick up on the change to that environment variable, you will need to basically roll out another set of containers. Those environment variables are not propagated live. Now, going back up to the kind of the first half of this slide, you can specify an image to pull container-wise that can either be from ECR, like where we pushed earlier, or it can be a container from some external registry, in which case you'll need to provide some way of getting credentials to ECS so it can go out and pick up that container image. Now, in the case of Fargate in particular, networking is pretty simple on the container side. You can expose ports TCP or UDP. We're going to expose port 80 because we have a little web server going on. And that's basically it. You're not going to see port mapping. If you want to communicate with other services within, or other containers within the same task, you can. It's just localhost port whatever. But at the end of the day, you can't say, well, yes, my container is exposing port 80, but I actually want it mapped to 8080 because I have something else that's exposing port 80. You actually do have to do some coordination within these little Fargate, for lack of a better word, VMs that you get from AWS. You can't do some of the heavier port mapping and such. So with that, let's actually go back into the console and set this task definition up. Now, task definitions do have revisions, and any time that you want to make a change, you're going to create a new revision. Those revisions are immutable, so keep that in mind, that you will wind up with a stack of these if, for example, you're changing the tag of your Docker image that you're pushing to match a release. And there is a maximum on the number of kind of active task definition revisions that you can play with. So just do this. Task role is none because we don't need anything once the container is running. Linux execution role is fine. This is ECS execution role is something that AWS will give you by default. Least amount of RAM, least amount of CPU. It says, hey, this is a free-for-all. Your containers can share across the entire board versus actually allocating to a given container. Add the container definition here. Let's hop over here. And we want to grab this tag here. Put that in the correct place. We don't need to soft limit memory. We need to port map port 80. Ignore health checks, environment stuff, and go all the way down to environment variables. We'll set a nasty little lowercase environment variable there. that. And not touch any of these other settings. Yes, you can attach local storage and such to ECS containers, but in our case, we don't touch any of that. So we have our container definition set up. We have our task definition set up. Continue ignoring additional options. And we now have a container definition inside a task definition. And we will be able to use that shortly. So, next step, it has to do with our load balancer. Now, from what I've seen, the setup of a load balancer to interact with a container setup with ECS is a bit weird with Fargate and such. So you have to kind of prime the pump by setting up this target group, which is the thing that an application load balancer routes to, and say, just route it to this random IP address. That IP address will never be successful in routing, but we need something to start things off. They may have fixed that in future revisions to this infrastructure, but that's the most reliable way I've seen to quickly get things up and running. Your mileage may vary here, but this does actually work consistently. So we'll set up a target group. We'll set it up to hit kind of any old IP address in our VPC, in our subnet. And we'll then use that as the target for the application load balancer that we'll set up after this. So we're back at this point into other AWS service land rather than the doing actual containery things. So target groups. And we'll choose IP addresses here because that is how ECS with Fargate attaches things. Port 80 because we're talking insecure HTTP back to the container. Health checks are fine. And then we'll set up the IP address here. This should work just fine. All right, and we've got our placeholder target group that we can then use as a target for our next step, which is actually interacting with the load balancer. So, load balancer, just kind of standard application load balancer stuff. Let's serve that up here. Actually, let me. So, we're going to do the kind of standard application load balancer thing of serving HTTPS and HTTP, but all we're doing on HTTP is telling somebody just please go and view the secure version. That's why earlier on we set up both ports 80 and 443 in our security group so that you could actually hit the load balancer on either and it would redirect in secure to secure. Again, this is not ECS specific stuff. This is rather AWS specific stuff and rather standard for AWS. So we'll use that target group in just a second here as the thing that we route port 443 to. It would help if they minimized the menu consistently when they loaded the page behind it, but AWS, known for their excellent user experience everywhere. And because I'm lazy and don't want to set up IPv6 on this, I'm just going to use IPv4. drop out the default security group and add the one that is a bit more restrictive. Switch to HTTPS here, and redirected our target group that we added earlier. The target group doesn't really work right now, but we'll fix that once we hook up ECS to it. We also need to get a TLS cert to actually serve HTTPS. And this is one of the nice things about using Route 53 for DNS. You actually have a nice integration to do domain validation for a cert, so we can do that quickly here. If I was going through like Let's Encrypt or something like that, then I wouldn't chance it for trying to get a cert during a demo. But in the case of AWS, it's not too difficult. Refresh this, go in here, saying pending validation because we haven't set things up in Route 53 yet. Create records. There we go. And this will take one moment to catch up on the fact that AWS DNS says that AWS Certificate Manager can actually assign the certificate. And we're good. All right, can close out of that, go back here, assign the cert, and the thing that 10, 15 years ago, it took an inordinate amount of effort to get HTTPS on your site, we just did. At this point, we have nothing else to configure here, so we can go ahead and create the load balancer. And then go right back into the load balancer and set up that HTTP to HTTPS redirect that I mentioned earlier. Fortunately, these are some intelligent defaults, so really all we need to do there is put in the correct port. No, we are not serving HTTPS on port 80. Hit the go button there. And now we have our load balancer set up to redirect on port 80 and serve the actual application that we haven't deployed yet on port 443. So, at this point, our next step is to actually go to Route 53 like I said I would, because we have a load balancer to set up. Again, this is a standard AWS load balancer thing. There's nothing container related about this either, but it does showcase how AWS Route 53 works well with the application load balancers, and the fact that application load balancers are just a bunch of CNAME records on DNS everywhere. So we've got that verification record here for the cert that we just set up. We're going to create one more. Use alias here. Yes, it is still an A record. It's not a CNAME. Hit the go button there. And fortunately, DNS on Route 53 is quick enough that I felt comfortable doing that and kind of having that be ready enough for us to actually demo with by the time that I get the last step of this process, which is the actual ECS service set up. So, let's do that now. Part of the ECS service is going to be setting up another security group, saying that the load balancer can talk to the ECS service over HTTP, and that's really the only inbound rule that's allowed. We don't need SSH at this point because we're never going to be shelling into containers. The containers will be spitting out logs and HTTP responses, and really that's it. And we'll set up the target group to actually do something useful rather than pointing to an IP address that doesn't actually exist. Now, you can, and I'll show you where this is, set up auto-scaling based on CPU request count or a couple of other parameters to scale up your Fargate containers, or if you're using EC2 instances, or some auto-scaling you can do there to deal with load. Likewise, you can decide to do kind of fancier processes for swapping out containers when there is a new setup for a service due to a container definition change or something like that. But we'll go with the simple rolling deployment one, as you'll see in a moment. At this point, we'll go back to ECS. Go back to the cluster that we had earlier. Add a service here. Default strategy is fine. We have only one task definition, so it selected that by default. It will select the latest version of the task definition by default. So there are a lot of nice things that you can just leave as defaults here. Do one task. Rolling updates. Okay. And one thing that we will have to do on each of these is, because we don't have networking built in at the EC2 level, you'll have to specify which subnets to deploy this into, and either select a security group or create a new one, which we'll create a new one now. And zoom out for just a second here, because this does not actually show the entire security group names, and that's a problem because we want to select the correct one here. Source group of this. Zoom all the way out. You select the long security group name, because that was one of the defaults, and I've had this AWS account for a while. Hit the go button there. And now we have the correct security group to say, this only accepts connections from the load balancer back to the application. We will assign public IP addresses on this. You may or may not actually want that. But again, the security group will tighten things down. Auto-assign public IP in the case of load balance stuff, you probably want that. So at this point, we can actually set up the link to the load balancer directly as we're setting up the service. Load balancer is set up correctly there. Go in here and tell it to use the target group that we had set up earlier. It still has those health checks and such that make sure that your /route or wherever you set up that health check to deal with is actually returning 200, or you go in and do, you can specify additional response codes there, but make sure that that health check actually succeeds. Otherwise, you're just going to wind up with container cycling, and you're not going to know what the problem is. Not that I messed that one up before. So here's your auto-scaling setup. If we wanted to, we could set metrics for increasing or decreasing the number of tasks running at any given point in time. And again, each of those tasks may have multiple containers in it, depending on how you configure the task definition. So at this point, we've gone through the steps of actually setting up the ECS service. We can hit the go button there. And then we'll wait for this service to come up. Now, this tends to take about a minute, and that's about Of course, this is going to be impacted with how big your Docker images are, but keep in mind that this is not Lambda. You can't push a release and then a second later it'll come up. There is a kind of lag time on these services coming up and being ready. So you'll have to factor that in when you're doing deploys. Google Cloud Run is better about this, and also in its ability to scale to 0. Fargate, you can't scale to 0. ECS, you really can't scale to 0 unless you're just doing scheduled tasks. It's something to keep in mind that you will have a minimum cost here of whatever your container definition or your task definition is times one instance. So at this point, we have a running task there. And if everything's set up right, it worked. Cool. So, and you'll notice that if you were looking closely at the definition of the actual container a while back, you saw that it was hello world with a couple of overrides there. Well, that environment variable was one of those overrides. So we wound up with hello PHP UK conference rather than world. And of course, we can do this. All right, so we have a functional but trivial PHP application running in ECS after 9 varying ease of use steps. A lot of those were not in the AWS control panel, in the ECS section of things. A lot of them were other kind of backing AWS services, but this is just kind of how you would build out a thing from scratch on the AWS side. A quick time check here to make sure that, okay, perfect. So there are a couple additional things that I want to go over now that we have this set up, because this is not the end-all be-all for setting things up. This is not necessarily a production environment per se. So for one thing, you may want to have some background processing jobs. Yes, you can actually run those as their own services, probably without a health check, probably without a load balancer in front of them, and scale that as needed, likewise CPU based or what have you. Or if you're wanting to do something on a cron job, then there is an entire scheduled tasks tab within ECS, within your cluster, saying, set up this particular task, potentially with environment variable overrides or even a command line override, and I would suppose that the command line override is what you're going to use more often if you're using the same container image for both serving web traffic and something that's on a CLI. So you can specify either interval-based execution or using kind of more or less standard cron syntax. And that link there explains a little bit of the idiosyncrasies of how Amazon parses that. So you can do this, and it'll set up an instance with Fargate, run through your task, and then when it exits, close everything down. And if you want to, you can hook that event and say, yeah, I want to post something to Slack, which is actually what we do for one of our batch processes overnight. Pretty handy. All logs for these containers do go into CloudWatch by default. So you'll get a log stream basically for any of these task executions for as long as that web server is running. You can kind of split things by service or by container, which is super handy. As long as you're pushing things out to standard error or standard out, then you'll get those logs and you can kind of look at them all in one place. Yes, CloudWatch logs is not the most friendly thing ever, but the data is all there. Also, yeah, this isn't prod. You're probably going to want, I don't know, a place to store data. We use AWS Aurora, or you might use Elasticache, or you might use something else, Dynamo, Doesn't really matter. Works the same way as you would with standard EC2 instances running everything on VMs. Although if you wanted to use IAM-based authentication, then you throw the permissions at the IAM role and move on. Speaking of IAM, I did not scope things down really carefully here to say, okay, only this particular secret or only this particular action. You're probably going to want to do that. You might even want to recreate that ECS execution role to your own specs to say that this particular role is only allowed to pull this particular container from ECR. Depends on your use case, but you can tighten those down significantly. It is AWS IAM. The possibilities are endless. Likewise, we use the default virtual private cloud, default IP space there. We could have changed that when setting up the ECS cluster. Didn't really need to in this case, though. Likewise, you may want to, and this is kind of just a general security practice, tell Amazon that you want to pay them a little bit of money to analyze various pieces of traffic in your system and tell you when, for example, you are logging in via your root account when you really, really shouldn't be doing that. And they'll have findings on that, and that's a good thing to enable, but just realize that that comes at a cost. And finally, this was all clicking around the AWS console. If you want something that's reproducible, then you're going to want to use Terraform or CloudFormation to automate everything that I just did. That's one of the projects that we will have set up internally pretty soon to get all that stuff into CloudFormation so that we could go from scratch to our own infrastructure without a whole bunch of headache of configuring things manually and maybe not getting everything right the first time. So with that, I'll open it up for any questions that you may have. Thank you for your attention here. Hopefully this has been informative and encouraging that if I can do this on stage with cell signal, conference Wi-Fi, whatever, and do that in a single session, then you can go from scratch to a full setup within ECS, serving web traffic over HTTPS in about a similar amount of time.
Yeah, thank you, Ian. This was great. Any questions? Yeah.
Just regarding the Fargate, right? Can we assign to the desired VPC that the Fargate, right, which we will be creating, so that we get proper network security connection between the database and the Fargate container?
Yes. So you saw that, and I'll actually go back to the task creation screen here, or the service creation screen. So if we created another one of these services, let's do this. So the way that you would, we can actually go through this. So this is the, ignore me calling that HTTP2. It's not running HTTP2. So you can determine the VPC here. I do not know off the top of my head whether you can have multiple VPCs in a single ECS cluster. But in the case of Fargate, it matters a little bit less because you can just create another cluster and assign it to the correct VPC or create a new VPC. So you can kind of set up your IP space here. You can set up your subnets here. You can say only this subnet in this availability zone and none of the others. And the ECS task or the ECS service can be assigned to its own security group or to set up with another one. So you've got some flexibility here. Again, I'm not completely sure on whether a single cluster can hit multiple VPCs, at least in networking only mode. It may be able to. In our case, we've used security groups in order to do that network segregation.
Hi. If you're building a cloud-native application, what do you find are the advantages of making it container-based as opposed to using like a function-as-a-service type thing like Lambda?
So container-based allows for more flexibility, allows you to start with your operating system level dependencies and kind of go up from there. I have done, actually did a talk back, Confu 2020, about using the Lambda layers to even run PHP on Lambda without much of an issue. The thing is that with ECS in particular, and I say ECS because Lambda now does support running Docker images on it. There's a little bit of extra cold start time on it, but you can certainly do it. If you're used to serving web requests and exposing port 80 or what have you within the context of Nginx plus FPM or the like, then you're going to be a lot more familiar with the way that ECS kind of handles things, particularly behind the load balancer and the like. By contrast, if you're working with Lambda, then you're going to be using Lambda's execution model, which under the hood is your application calls their endpoint for the next task to do. It gives you a response with a Lambda proprietary JSON format. You base64 decode your request body and that sort of thing, and you make another call to the HTTP endpoint when you're done with the task to send the result back, and then Lambda hands that back off to the consumer or to the API gateway consumer or what have you. And it's a bit different model on doing things now depending on the abstraction, on the framework that you're using. Like if you're using, say, Laravel Vapor, then it's all abstracted away from you and you don't really care. Or you're using Bref, you don't really care. But the execution model is actually very different under the hood versus your standard HTTP side of things. One important piece of that is that the way that you get concurrency in Lambda is that you have more Lambda invocations, which usually is fine, but because your CPU and RAM scale together in Lambda, if you have something that's for some reason CPU intensive, or you have something that's RAM intensive, or you have something that is just waiting for I/O somewhere else intensive, then that may not be the most efficient way of running your application. Whereas, if you're container-based on something like ECS, then you can have multiple requests hitting that container at the same time, just like you would a standard VM running Nginx and FPM. You can set your FPM pool to whatever it is and serve concurrent requests that way. And so it really depends on what execution model you want to work with. And in our case, the additional flexibility that container-based setup provides and the additional ability to have multiple concurrent connections going to a single container was something where it's like, yeah, this is what we're more familiar with. This is easier to test locally because we can run this in Docker Compose. Yes, AWS SAM works. Yes, serverless framework exists. But the tooling, at least in my opinion, for our use case, was a bit better to just have everything in containers. And at that point, it's like production basically works like dev. Hopefully that answered the question in a rather long-winded way.
Yeah, no, that was a really good answer. Thank you.
Cool.
One other question I had is, what do you think is the best way to automate the deployment pipeline with something like this? I know that's a very broad question, but
Sure.
How do you do it?
So we're actually in process for doing that via GitHub Actions. There's a PR open to on our core repo that basically when we merge into our development environment branch, then that will get pushed automatically. The container image gets pushed to ECR. Once you have that level of automation, then you can do things like tagging based on a commit hash, then turn around and create a new task definition revision using that commit hash, and then turn around and swap that task definition revision in at the service level to roll out that new version of the application. That's basically how you would end up doing it. So it's it's a Docker push from GitHub Actions, which there are a couple of different ways to authenticate that. There's some fun you can do with OIDC around that, so that you don't have to throw an access key and secret into Actions. Of course, AWS might prefer that you use code build, but I don't know anybody who actually does that. So you take your GitHub Actions bit, you build your container on Actions or on one of your self-hosted Actions runners. You push that to ECR, and then you call the necessary APIs to say either do a force reload of the service if you're using the same tag, or you would update the task definition and then update the service and say, point to this new task definition, and at that point, it will redeploy. And of course, you have a couple of options around there of doing like blue-green deploys if you want to pull code build in there anyway. But yeah, that general workflow is how we will be doing our deploys in the very near future. Because startup things, deploys are still happening somewhat manually. It's a script run on my local because do as I say, not as I do. But yeah, we're imminently going to be on GitHub Actions, and that'll also allow us, since that's going to be a lot more kind of infrastructure as code in that direction, we'll be able to start using ARM instances on Fargate without much issue, rather than the brick wall that I'm running into right now of like, hey, I can't click it on the console, so it doesn't exist.
Any more questions? Yep.
Hi, I'm just wondering how the costs show up compared to using something like AWS Lightsail.
So Lightsail, I'd have to look again, but basically the comparison that you would be making is between the Lightsail container service and ECS. And pricing, as I recall, is comparable. Lightsail container service, I believe, has bandwidth costs baked in for the first 100 gigs, 200 gigs, whatever it is. So if you are pushing a fair amount of traffic that way, then really your issue is not with ECS pricing, it's with the absolute highway robbery that is AWS bandwidth costs. But yeah, Lightsail has a somewhat equivalent service in the Lightsail container service. There is a bit less flexibility on that, so I haven't dug into a whole lot of detail on exactly where things fall there. I do know that Fargate, in particular, which is you don't pay for the ECS control plane, you just pay for the actual instances underneath. Fargate is, at least in the US regions, I think it's like 4 cents per vCPU hour, and like 70% less than that for spot, and then a small amount of money per hour per gig of RAM. Whereas in the case of ECS, or in the case of Lightsail container service, it's kind of all built in as one hourly price with a few less knobs to play with. Again, that's kind of the apples to apples comparison. If you're comparing with Lightsail's actual VMs, their equivalent of EC2 basically, then really what you should be doing is comparing between that and EC2 instances running within ECS, because you can totally tell ECS to run against EC2 instances.
Brilliant, thank you.
Sorry for the kind of nondescript answer of like, I don't know the pricing off of the top of my head, but it's, if you want to compare apples to apples, it is container service versus this.
Yeah, any last question? All right, thank you, Ian. Give him another round of applause, please.